Hello guys, in this video we are going to discuss the solution of the problem nth natural number. So let us look at the problem statement. The problem statement says given a positive integer n, you have to find nth natural number after removing all numbers containing the digit 9. So for instance, if n equals to 8, we are returning 8 because in this sequence there isn't any 9 and 8 is the 8th natural number. Similarly, if n equals to 9, then we are returning 10 because after 8 there is a 9 which we have to skip, and then the ninth natural number is 10 and that is what we are returning. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us express the numbers by skipping 9, and then let us try to find the relationship between the natural number and the number which we are expressing by skipping number 9. So let us do that. So let us list down the natural numbers. So this is 1, 2, 3 and so on. So let us say these are the first 30 natural numbers starting from 1 and all the way till 30. Now if we have to skip 9 and write down the natural numbers, so let us write it down. So then 1, 2, 3 until 8 it is fine. Now since the next natural number is 9 and we have to skip 9, because of which the next natural number after skipping 9 will be 10, and that is what will come over here. And similarly for rest of the cases, so this will be 11, 12, 13, 14, 15 and all the way till 18, and again after 18 the next number is 19, and since we have to skip 9, so because of which the next number will be 20, and so on till 28. Now the next natural number after 28 is 29, and since we have to skip 9, because of which the next number will be 30. And in this way, if you see, we have represented the first 30 natural number by skipping 9. Now let us perform one more experiment, which is to express number in the base of 9. What do I mean by this is, so let's say n is a decimal number, and if we are representing this n in the form of decimal number, then the digits we'll be using is 0, 1 all the way till 9. So these are the digits which we'll be using if we are representing numbers in the form of decimal number. Similarly, if we want to represent number n in the form of base of 9, then we just have to use the numbers from 0, 1 all the way till 8. So what do we want to do is we want to represent each of the number in this format, which is base of 9. So let us do that. So this number will be 1, 2, 3 till 8. The numbers remains the same. So let us represent 9 in the base of 9. So we want to represent 9 in the base of 9. And the way we do this is by dividing 9 by the base, which is 9. So we divide it by base and this becomes equals to 0. And whatever is the remainder will become my LSB, so 0. And then the quotient, which is 1, has to be again divided by 9. And this time the quotient will be 0 and the remainder will be 1. And once we obtain quotient as 0, we stop this operation. So over here, the remainder is 1 and that will come over here. So in this way, 9 will be represented in this form. So this number will become equals to 10. Similarly, let us represent 10 in the form of base of 9. So 10, if we want to represent in the base of 9, then this will be equals to 10 divided by 9, goes 1 times, remainder is 1, so 1 is our LSB. Then again this 1, which is our quotient, has to be divided by 9, so 0 times it goes, and this will be 0, and then the remainder is 1. So the remainder will come over here, and since the quotient becomes equals to 0, so we stop this operation. So this 10 becomes equals to 11 in the base of 9. Similarly, let us pick any other number. So let us say we want to pick 29 and we want to represent in the form of base of 9. So let's take 29 and we want to represent in the base of 9. So 29 divided by 9, 9 3 27. So the remainder is 2. So LSB is 2. Now 3 quotient will be divided by 9, 0 times, and this will be 0, and then the remainder is 3. So 3, and since the quotient becomes equals to 0, so we have to stop this operation. And in this way, if you see, 29 will be represented as 32. So let us do that. So 29 will be represented as 32. And similarly, as you would have guessed, if we represent a number in the base of 9, we will get the number which we will obtain by skipping 9. So, in a sense, this problem gets translated to, given a number n, represent this number in the base of 9. And this is what we are going to do in order to solve this problem. So let us work with an example in order to develop a logic. So let's take a larger number. So let's say the number which is given to us is 84. And we want to represent this 84, which is in decimal, into base of 9. So the way we will be able to do this is, first what we want to do is we want to divide 8 by 9. So let's divide this. So the remainder we obtain is 3. So 3 will come to the LSB. Then this 9 is something which we are going to divide again by 9. So 1 times. So this becomes equals to 0. So the remainder is 0 over here. And then comes 1, since the quotient is 1. And then 9 divided by 1. So this is 0, 0 times, and the remainder is 1. And this is 1. And since the quotient becomes equals to 0, because of which we are going to stop our operation. And this is how we will be able to represent 84 in the base of 9. Now let us try to develop a logic. So the first thing which we understood is the number 84 reduced to 9. Then this number gets reduced to 1. And once the quotient becomes equals to 0, or the number gets reduced to 0, we are stopping the operation. So from here, the logic which we are able to derive is while n is greater than 0 or n is not equals to 0. So our loop will iterate while n is greater than 0. Now the next thing which we understand from here is these numbers, as you can see, are remainders. So this is the remainder which we are going to store over here. And how do we find remainder? Well, the remainder can be obtained by n modulo 9. So if you see, we are dividing the numbers by 9, and whatever is the remainder is what we are keeping it over here. And the final thing which we need to understand is 3 will come over here and then comes 0. So the 0 is coming over here and 1 is coming over here. So what do I mean by this is 3 is coming at units place, 0 is coming at tens place, and 1 is coming at hundredth place. And this is what we need to maintain when we form our answer. So to begin with, what we are going to do is we are going to take a p which is equals to 1, which typically represents the unit case. And once we go on to the next iteration of the loop, p will be increased by p into 10 so that we can come to 10th place. And in the next iteration, again p will be multiplied by 10, which will move our p to 100th place, and so on. And in this way, we will be able to represent a number in the base of 9. So let us now write a pseudocode for this. So let us say we want to represent in base of 9 and a number n is given to us. So let's have our answer, and initial value of answer equals to 0, p as we have discussed equals to 1, and now let us iterate on n while n is not equals to 0, and then let's have our remainder. So remainder, as we know, is equals to n modulo 9, and then what is our answer? Well, answer is equals to answer plus remainder, and this remainder is at which place? Well, it is at p place, and that is why we are multiplying it by p. So let me explain it from here. So let us say we are at this stage. So over here the remainder obtained is 1, and as we know, p will be 100 at by this time. So p equals to 100. So our answer will be equals to, so initial answer will contain just 3 plus, since this number is 0, because of which 0, 3 is just 3, plus remainder equals to 1 into 100, and that is how 103 is obtained. So that's exactly what we are representing it over here, which is answer plus remainder into p. And once we have done that, let's increase our p by p into 10 and update our n by n equals to n divided by 9. And in this way, we will be able to get our answer, and towards the end, all we have to do is return answer. Folks, just one minor optimization. So we don't have to really do it in 2 steps. What we can do is we can write down answer equals to answer plus n modulo 9 into p, which is essentially the same thing as what we are doing it over here. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. So the Python implementation is pretty much the same as what we have discussed. Answer equals to 0 and p equals to 1, while n, and then we are updating our answer, n and p, and towards the end we are returning answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So again, it is the same, folks. Answer, p, and then we are iterating on n while n is not equals to 0. Answer equals to answer plus p into n modulo 9. Then n and p are updated, and towards the end we are returning answer. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.